Hello and welcome to part 2 of Teaching Times Tables. In today's session, we're going to be looking at some practical suggestions of things you can use in the classroom. Again, I would like to thank the teacher research groups from Archimedes Maths Hub and the London Central Maths Hub working with Camden Learning for their support. As with anything to do with teaching, assessment is key. To have maximum impact, you need to know not only each child's starting point, but also their attitude to maths and the support they have at home. Take some time now to reflect on your own class. Do you have a list of tables that each child needs to learn? Have you engaged parental support with this? What barriers are there? Pause the video and jot down some notes. In this session, we're going to look more closely at what the research suggests works to develop pupil recall of times tables. Charlie Stripp from the NCUTM, in his argument for learning automatic recall of times table facts, states that learning mathematics involves knowledge of three main types: factual, procedural, and conceptual, and research evidence suggests that all three should be developed in parallel. Neglecting the factual inhibits the development of procedural and conceptual knowledge and damages mathematical learning. It is because of this that we need to be relentless and uncompromising in our approach to teaching times tables. This requires us to have clear knowledge of which times tables individual pupils need to learn. Not just they need to learn their eights, but they still struggle with 7 times 8 and 12 times 8. The easiest way to do this is through a chart, printed off on your wall so that you can mark off against it once the children can prove their knowledge. We know that whole class challenges work for most pupils and that success motivates. However, it's worth considering a more individual approach for those who are struggling. Assigning a teacher as that pupil's times table champion is a great motivator. It could be the class teacher, a teaching assistant, or another colleague, perhaps even the head teacher, who knows which tables they are working on and quick fires questions at them or challenges them to a competition. Rewards work in the short term to motivate. However, the cheapest, easiest reward is a quick phone call home to thank the parents for their support in helping their child learn their 4 times table and let them know that the next one they're working on is their 8s. Children who have strong number sense will automatically use what they know already to support them to find unknown facts. Developing number sense starts in early years when we ask children to find another way of making 4 and another way and another way. However, as children progress through Key Stage 1 and into Key Stage 2, unfortunately, through the rigid teaching of procedures, children can become fixed on finding the correct way to calculate. If we explicitly teach these strategies and give them permission to use them by acknowledging and celebrating number sense in lessons that are not specifically teaching times tables, it allows children to see the links between multiplication facts and using derived facts and doubling to find an answer. It's not preferable to just learning them. However, it's far more preferable to skip counting or singing whole songs to find the correct fact. Children need to see the innate flexibility of number. We know that multiplication is commutative. In other words, the factors can be swapped around and the product remains the same. So a simple strategy is to ask children to think of which times tables they are most confident in and always putting those as the first number when they appear. Joe Bowler's work on developing number sense would support you here and can be used really effectively in maths meetings. Many of you will have seen the Jill Manser video where she uses a counting stick to teach a group of adults the 17 times table. Here, Nicole Winfield uses the same techniques to teach the 4 times table. Her real audience for this film is primarily parents. However, as teachers, we can learn a lot from it too. As you're watching, I'd like you to consider the techniques and strategies she uses to support that understanding of the 4 times table. There's a sheet in the Padlet which you can record these ideas on.
Hi everybody, I'm Mrs Winfield from Wyndham Primary Academy in Derby, and I'm here today to show you how you can use things from your home to recreate a counting stick that will help your children recall their times table facts. Now I'm going to pretend that there's a class of children in front of me, so all that you'll need to do after watching this video is head over to our top tips video, which is sat nicely with this one, and it will explain my thinking behind how to set this up and will help you translate the classroom into your home. Okay, so we're going to start by exploring our 4 times table today, and we start our count at 0. and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. We start our count at 0. 1 lot of 4 is 4, so we don't need this to help us remember anymore. 1 lot of 4 is 4. Okay, let's count once more. We start our count at 0 and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. So we start our count at 0. 1 lot of 4 is 4. Double 4 is 8. So 2 4s are 8. So we don't need that one either. So we begin our count at 0 and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. Start our count at 0. 1 lot of 4 is 4. Double 4 is 8. So 2 4s are 8. Double 8 is, double 8 is 16. So 4 4s are 16. Okay, getting a little bit more exciting now. Can you remember our missing values? Let's try. Starting our count at 0, we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. Start our count at 0. 1 lot of 4 is 4. Double 4 is 8. So 2 4s are 8. Double 8 is 16. So 4 4s are 16. Double 16, where would that sit? Double 16 is 32. So that means 8 4s are 32. Can you remember that one? Okay, so we've got our doubling facts now. And we start our count at 0. We count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. We started our count at 0. 1 lot of 4 is 4. Double 4 is 8, so 2 4s are 8. Double 8 is 16, so 4 4s are 16. And double 16 is 32, so 8 4s are 32. What else can you tell me about the values on my counting stick or my number line? 10 4s are 40, because 40 is 10 times the size of 4. So I can also take that one. 10 4s are 40. Right, okay, let's start again. We start our count at 0 and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. Start our count at 0. 1 lot of 4 is 4. Double 4 is 8, so 2 4s are 8. Double 8 is 16, so 4 4s are 16. And double 16 is 32, so 8 4s are 32. Now, we also said that 10 4s are 40, because 40 is 10 times the size of 4. But how could I use that to find halfway? Half of 40 is 20. So if 10 lots of 4 is 40, 5 lots of 4 must be 20. Half of 40 is 20. Okay, now we're getting close to having a completely blank number line. So we start our count at 0 and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. Start our count at 0. 1 lot of 4 is 4. Getting good at this by now. 1 lot of 4 is 4. Double 4 is 8, so 2 4s are 8. Double 8 is 16, so 4 4s are 16. And double 16 is 32, so 8 4s are 32. 10 4s are 40, because 40 is 10 times the size of 4. And half of 40 is 20, so 5 4s must be 20. Okay, if we start our count at 20 and we count on 4 more, we get to 24. So 5 lots of 4 is 20, so 6 lots of 4 is 24, because it's 4 more. Easy, that one. Okay, so let's start again. We start our count at 0 and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. Starting our count at 0, 1 lot of 4 is 4. 2 4s are 8, 4 4s are 16, and 8 4s are 32. Hopefully we can remember that one now. So 10 4s were 40, because 40 is 10 times the size of 4. And if you can remember, half of 40 is 20, so 5 4s are 20. Now we didn't start our count at 0 this time, we started our count at 5 lots of 4. We started our count at 20 and we counted on 4 more, we got to 24, so 6 4s are 24. If we count on 4 more again, because we can see just a change in our ones, we get to 28. So 4 more than 24 is 28. So what does that one tell us? That one tells us that 7 4s are 28. Okay, let's start our count at 0 and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. Okay, so we start our count at 0. 1 lot of 4 is 4 and double 4 is 8. So 2 4s are 8. Double 8 is 16, so 4 4s are 16 and double 16 is 32. So 8 4s are 32. What else did we remember? Oh, that 10 4s are 40. 40 is 10 times the size of 4. And from that, we could work out half of 40. Half of 40 is 20. So 20 is the same as 5 4s. Okay, now if we start our count at 20, rather than starting our count at 0, we can count on 4 more. So 20 and 4 more is 24. So 6 4s must be 24. 4 more than 24 is 28, so 7 4s must be 28. And then we're left with these values. Which one to choose next? This one. I like singing this one. I like singing 3 4s are 12. Even with my out of tune pitch, but we go 3 4s are 12. Can you do that? 3 4s are 12. Just helps me remember it. Okay, let's keep that one in the bank. So we start our count at 0 and we count 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. This one is now sat all on its own. We can remember that one a little bit better. Which one sat on all on its own? 36. Okay, we'll remember that one. So let's see how many facts we can recall. So we started our count at 0 and 1 4 is 4. I bet you can do this by now without me having to ask you any questions at all. Double 4 is 8. So 2 4s are 8. Double 8 is 16, so 4 4s are 16, and double 16 is 32, so 8 4s are 32. 10 4s are 40, because 40 is 10 times the size of 4, so half of 40 is 20, so 5 4s are 20. And if we start our count at 20, rather than starting our count at 0, we can count on 4 more than 20. 20 and 4 more is 24, so 6 4s are 24. And 4 more than 24 is 28, so 7 4s are 28. And we had that one that we sung together, 3 4s are 12. So all that's left to address is this one that's on its own. Poor 36. But we can say that together, can't we? We can say 9 4s are 36. Now I wonder if you can think of a way that I can calculate that. Did you get the same way as me? I thought I could start at 40 and count back 4. So using my knowledge of counting back. So if start our count at 40 and count back 4, we can get to 36. Okay. I think that we can go all the way through. So reminds me, we always start our count at 0. And we count 0, 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. Wow, that is fantastic. Using only items in your home, you have recalled the whole of the 4 times table. Okay, head over to the top tips video right now to see how you can explore this even further.
Evidence suggests the scattergun approach to teaching times tables doesn't have as much impact as teaching them systematically. suggesting that we have a table of the week approach. In early years and Key Stage 1, there's a bank of evidence around the importance of integrating maths opportunities throughout the day, and this can specifically apply to times tables in Year 2 to 6 too. Make the most of those opportunities that could be given over for times table chanting or quickfire questions. Maybe an exit question to leave the classroom for break, or a PE provider can lead them in a chant as they get changed. This image is from Shanghai and is a handout that children are given to show that there are only 21 facts they need to remember to know their 1 to 9 times table. There's a copy of this in the Padlet too. We know that some times table facts are trickier to remember than others, so using rhymes or memory aids like 5, 6, 7, 8, 7 times 8 is 56 can help. Chanting is a classic for learning times tables, and it works. What do you notice about the rolling numbers chant here? Have you ever tried it? If not, and you'd like a go, the chants and a how-to video by Bruno Reddy, creator of TT Rockstars, are on the Padlet too.
I've been telling everyone how good you are at maths.
No lie, true say.
Can you roll your 9s?
Yes.
Team, good as gold. Let me see your fingers roll the 9s.
9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108. Whoop, there it is. I said whoop, there it is.
Team, good as gold. Let me see your fingers roll the 3s.
Yeah. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33, 36. This team's going on. Oh yeah.
Team, good as gold. Let me see your fingers roll the 6s.
Yeah. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60.
And Team A says,
66, 72, how do you do? We can do our 7s too.
Team, good as gold. Let me see your fingers roll the 7s.
Yeah! 7, 14, 21, 28 and 35, 42 and 49, 56 and 63, 70, 77, 84. If you want, we'll give you more.
Team, good as gold. Let me see your fingers roll the 8s.
Yeah! 8, 16, 24, 32, 40, 40 down here, 40 up there, 48, 56, 64, 72, 80, 80 down here, 80 up there, 88, 96.
KSA, so smart in here.
Yeah! 4, 8, 12, 16. This is how we roll our 4s. 20, 24, 28, 36, 36 and 40, 44, 48, no doubt. We rock, It's KSA in here. We'll show you all we know. We are getting so smart. We are getting ready. With a little work hard and a little be nice, With a little work hard and a little be nice, It's KSA in here. We'll show you all we know. We are getting so smart. We are getting ready. With a little work hard and a little be nice, With a little work hard and a little be nice, It's KSA in here. We'll show you all we know.
And finally, making connections with place value will support all learners, but can be a quick and easy challenge for your pupils who already have automatic recall of times tables. Can they use what they know to multiply decimals? On the Padlet, I've created a reflections and actions document for you to complete, identifying things to do more of and, importantly, things to do less of. We know that for any change to be sustainable and have impact, it has to be countered with a decision to stop doing something. So if lots of your allocated time is spent on TT Rockstars, it's worth thinking about dropping some of those sessions and putting some different actions in place. We know there's limited time within the curriculum and we can't just keep stretching it by adding more and more in. It's useful to have a whole school approach to teaching times tables. So once you have considered the changes you would like to make, I'd recommend getting together as a school or department to share your reflections and to plan your next steps. Thank you.